So, what I actually didn't have any real agenda to talk about. I just wanted to see what they will evolve into and see what we can come to some kind of conclusions. Well, the topic of the talk should be like opensc 2015. Well, but in fact, actually, it doesn't have maybe much to do with opensc as a project, but more about the whole ecosystem, how the things could look like in 2015, or is the future bright or is the future dark? Well, the title page is black like funerals, but actually it's not that bad. So before trying to make any kind of plans or predictions for the next 5 years, I come from Estonia. It used to be a Soviet country. They used to love the 5-year plans. We'll just take a look back when I started to work with opensc. It was 2004 or 5 or something like that. And just to see what has happened during the past 5 years, to maybe see some hints or insight into the future things that might happen. So just did a code checkout to see how the code looked back in 2005. And at the end of 2005, not in the beginning unfortunately, there was 17 different card drivers, like support for roughly 17 different cards. Right now the number is 30. Well, it's pretty nice, almost double. And when you take into account that some of the cards are actually already long dead, many are in a state that there's code, that there's actually no one with an actual card to test it, or no one actually knows if it works. It seems actually a huge number, like 30 different card drivers. But it's a pretty old project. It started in 2001, I think. And one of the problems of the many card drivers has been the lack of standardization. All the card drivers implement kind of a proprietary reverse engineered something similar command interface. But for example, in the Estonian ID card with which I work most was one of the cards that was set in stone before package 15 even existed, which means there's no relation to package 15 in that card. ISO 71615, which is something like ISO standard for the package 15, it also appeared in 2004 as a standard, but usually standards are either like documentation of existing reference implementations, or they set some kind of industry common views to stuff that actually isn't implemented. When you take Java cards, for example, we have a Java card 3 specification for a few years already, but none of the card vendors actually implement or provide you with cards that provide Java card 3 compatibility. We have now the European citizen card. There's the PIV standard in the United States. They all describe the command interface to a card. So that's something that should maybe limit in the next 5 years, that we won't have so many new card drivers because we have standards which should help it. We should have standard drivers. During the past 5 years, I don't know the numbers, but several European Union member states and other countries have introduced EID programs. They're all somewhat different, all are somewhat similar. For example, in Belgium, I think the project has been as long as 5 years, or also from 2004 or 5. There's Spain, Italy, Portugal, there's a new card coming in Germany, there's something in other countries as well. But anyway, that's something that was set as some kind of policy decision that by 2010 there should be interoperability, for example, for digital signatures in the European Union. We're not there yet, as we saw from the presentation by Samuel. In the past 5 years, there's been a kind of a huge stabilization in the system APIs and standards that I used. Back in 2004, for example, there was, when you had a PIN-pad reader, they existed. Even I think some of the models are still sold, but there was no real standard for using PIN-pads. There was, but that standard, the CT API, is now long gone because it wasn't any good. There wasn't even CCID I don't know again the dates exactly, but I think it was also 2000 something, like 4, when the CCID matured. Right now, all the smart bit readers you can buy anywhere, most of them are CCID.
Do they support extended APDU or CCID as well?
That's another issue. For example, extended APDUs is one thing I forgot, but it's also very important in the context of smart cards. We have pin pads. In 2004, there was some industry consortium providing some kind of specification that's now part of the PCSC ref specification, which of course is not maybe the best specification because it has no public review. It has Windows guys doing it, which means, you know, when you have a big alien machine, you're screwed very often. So, but there are standards, which is really, really nice. In 2004, for example, there was Mac OS 6, but it didn't come with a PCSC framework. It appeared in OS 6 10.4. But now it's included in the system. It's kind of the only real viable solution for cross-platform smart card use. Well, talking about OS 6, that before the important client platforms were Linux and Windows, but then came OS 6, which is now, I don't know, depending on the country, from a few percent, 10%, something like that. It's kind of important. Luckily, it's Unix, so we can use some of the tools, even though Apple screws up the open source software very often, very heavily. It's still better than Windows in some situations. During the past 5 years, things like platform plugins that plug into the overall structure or overall services of the platform, like on Windows and Mac OS X, have emerged. That's something that has been discussed heavily here today. Is the DECASS 11, which is like the platform API, or the platform plugin for Linux, because there is no common framework. There is no such thing like Win32 API or like Crypto API on Windows or the TokenD or Mac OS 6 that all the, so to say, native applications use. In Mac OS 6 you don't have, or in Linux, sorry, you don't have like native applications. You can take a fight and GNOME or Kali thing, but that's not the point. The point is that there is no like cryptographic platform. There is just a set of libraries you can use. Well, another thing I noticed is evaluation or maybe detaggization of certificates. You know, usually 5 years ago, certificates were all good. You saw the padlock icon, yes, secure. But now what they tell you, unless you see the green bar, and not just green bar, but with the special, light of green, be afraid, be very afraid, drop the keyboard and run away. Just something to think about. And from the smart card point of view, the reason why there were so many card drivers, there are so many card drivers in opensc is that most of them target a specific card operating system. They target a specific command interface, proprietary, not documented, whatever. But with the rise of the different interface standards like DIV and ECC, most like huge card vendors have, maybe even card vendors, but the silicon vendors offer every kind of stuff. But the application vendors have settled on Java cards as the open platform, which means you can have your PIV application and you can choose your vendor for the card. Again, something to think about. So, what could happen in 5 years in the world of smart cards and open source software? Well, we can try to develop the open source software just, with what do we call it, eyelids, without looking anywhere what's happening. But it's not really a productive thing to do. So in the next 5 years, not probably, but we're going to see things that will happen inevitably. We can't avoid that. The most obvious is new algorithms. Right now, when you take any kind of cryptographic software, what do you mean, like public key means RSA. like OpenSSA is the kind of the wonderkid of the, or the wonderchild of the open source cryptographic software. I think it was 1 month ago when 5.7 version was announced to the ECDCA support, the Elliptic Curve PSA. In a few years, when you take the different government or industry recommendations for new algorithms, we need to deal with it. We need to deal with elliptic curves, we need to deal with, other than MD5 is long dead, other than SHA-1, there will be SHA-3 in 5, or SHA-3, yes, in 5 years. The recommendations for RSA keys, like 2048 bits should be the standard since, I think, last year already. So, which again, from smart card technical perspective, brings us to the problem of extended APDUs, because the buffer to the smart card will be longer than the short APDU 255 byte limit. We're going to have to hide 1 or 2 more bytes somewhere. So it brings again a lot of trouble to the driver writers. But it's something application developers should really heavily think about. You know, RSA will run out of juice sometime, and we need to be prepared. We need to be prepared in our application designs, in protocols, in software stacks, and so on. And there's Ghost, for example, another interesting protocol to think about. So, in the next 5 years, even more people will have the ID cards that were starting to roll out in the last 5 years. Which means that even if the cards are out at the wallets of people, they don't maybe use it. They don't maybe use them because they don't have any kind of the services or software to use them with. But if more and more people will have them, more and more people will think, how can I use it? Which means there will be a much broader audience for different applications. And we need to think about it, how can we accommodate all the people, how can we make the software so usable that actually your grandmothers and brothers and mothers and whoever you say don't use currently smart cards, like, you know, in a corporate environment or a hacker environment, but you will have every European citizen, most of them will have some kind of smart card they can use, and probably the government will invent ways to use it. So, again, something we can't avoid is, we can talk about paljak 11, but the open source is kind of a broader thing than just the Linux and Linux world. So open source exists, for example, opensc works on Windows, works on Mac OS X, and these are closed platforms, proprietary. Even though Mac OS X claims that it's open source, and for example, the software we use to build the native plugin for Mac OS X is, so to say, open source, but it doesn't mean it, you know, it works like open source. The next final release breaks everything. When you ask for support, there's no comments. When you look at code and you scratch your head and what the fuck is this? Then no one to ask any kind of questions. It's not open source. And native applications, do we like it or not, will use something that, you know, works smoothly for the desktop experience. They will use Microsoft APIs. For example, the fact that the Starship or the flagship open source browser right now, Firefox, doesn't use the crypto API in Windows, doesn't use the built-in certificate store and the built-in drivers in Windows, that's kind of, actually, that's a legacy. That's a very bad choice by Firefox guys. When you take the new, my favorite browser, Chrome or Chromium, it works with crypto API on Windows. Very smooth experience. It works with the native APIs on Mac OS X, the best browser, because software it just sucks. It does some stupid things, certificate selection. It's not really usable. 1 week ago, or a few days ago, the Linux version of Chromium grew actual support for smart cards. You can use, it asks for a ping. Before it didn't use to do that. The native builds work flawlessly, much better than Firefox with smart cards. Through paljak 11, because there is no platform on Linux. Something we should think about. What I wanted to say is that Chromium is open source and it is doing the right thing, and it is doing the only thing it can do on Linux, because there's no other option than paljak 11, even though it's not the best, as I said before. So, what will also probably continue is the debate whether smart cards and any kind of hardware cryptography is like a three-letter organization, multi-million-dollar investment, hidden expenses and so on, or it's a commodity for grandmothers, fathers, me and you, whoever. That's the thing, it's, for some of us it's a good way to make money and say it's so complicated, it needs to be expensive, it needs to be very high level, because it brings us more money. Oh, nothing here. Right. Other things, the milk river, the milk rivers, that's the same in Estonia, that there are porridge mountains and milk rivers and everything is, pink and shiny and cozy. Actually, something is missing. I had a few more lines, I need to invent them. First of all, that due to the standards, hopefully, in 5 years we will not see another similar explosion of card drivers in OpenSC. You will see actually that the number shrinks because we're going to have standard interfaces. We have more standards, more card vendors and companies actually stick to standards when they issue the cards, the formats, and so on. So we're going to have a fewer but more supported smart cards. I'm sorry, actually, it will switch now. So the perfect future would be that we'll need to grow usability. This has been demonstrated over and over again that the user experience of any kind of the usual problem of security is you need to balance between the hardness of the security and the usability of the system. We need to grow usability somehow. Because if we want to win the debate, will it become a commodity or will it remain as, so to say, big iron business? If we want to become a commodity, what I think everybody would like to see, we need to become usable somehow. So the usability of crypto is basically my wet dream. And what the usability means, well, one of the biggest problems which has also been discussed before, is the enrollment or the card management or the personalization or initialization. Well, if you get a card from a government or your company or something, you don't really care about it. But if you want to make crypto usable so that you can use it in your own invented environment, you want to be able to personalize your own tokens or use some token for your home server to plug it into your wireless router, and when you connect with SSH, you will actually authenticate against the hardware token in the wireless browser. You need to make that somehow manageable. Diversity versus interoperability versus Well, the thing with Linux is that one of the tries to make the thing more homogeneous, so to say, is the Fedora crypto consolidation, which takes the very easy road that we're going to use NSS. We're going to be happy, and you're going to have all the fine things that Windows has. Well, Linux is famous for flame wars. So we want to create one again, which is the right one, GNU-TLS or OpenSSL or NSS or whatever. I doubt it. That I would like to choose. I would like to choose based on my personal preference, my maybe application writer's preference, something like that. So the diversity is nice. I don't think it should be dropped, but we need to get interoperability so that applications written with GNU-TLS could work with the same card and an application written in OpenSSL with OpenSSL in a very similar way. So yeah, that means accessing objects. That means like everyday use when you go to some website and you need to authenticate with a key and a certificate should work. like similarly, but you could have the option to choose something. And another thing is that what most of the SSL libraries actually do, and what Steph very brilliantly pointed out, that the way to distribute or talk about trust, I put it in small tricks because it means different things. Enforcing policy or like setting the trust anchors or something like that, it needs to be communicatable between different applications to work it out. So the proposals, what Steph said about making Pegasus 11 usable across applications, that's something really, really great. And the tough tasks to do is integrating with proprietary platforms, maybe not really that interesting to the open source developers who work on Linux, but for an opensc as a project which should bring the open source promise to everyone without any discrimination on the platform. This is a tough task because for example, for Mac OS X, we depend on the Apple guys, how they do their stuff. When the Steve Jobs wanted to do an announcement on the stage, they won't tell us anything. With Windows, for example, it would be nice to have, when you plug in a card that doesn't have any kind of a vendor support in Windows 7, for example, like you could load the opensc, the open source software. But for example, it cannot do it because Windows policy disallows open source auto-discovered drivers. So again, it's something to think about. And another tough task to do is to actually move the open source to the other side of the chip interface. Now, right now, all the software talks about how to make use of the card, but actually you can put the open source software into the card. And there is no solid solution there isn't a solid Java card tablet right now. There must be one, the tool came, they are all old and not really up to date anymore. Basically, that's it. So the tough task is the consolidation, which is down the easy path. Just say that this is our policy, which can be done in a closed project. We're going to use this, and we gain everything versus interoperability, which is difficult. But this is something Linux has this far been quite good at. For example, when you take GNOME versus Kali, there's this free desktop that kind of assess the common things and the common tools and common APIs that both projects and other projects can use to gain interoperability. So looking into interoperability in both practical and theoretical ways is the most tough task, in my opinion. That's it. Questions? I'm over my time limit.
Is there a meeting somewhere to eat afterwards?
Yes, there is. Actually, it's 9 o'clock, and we're going to have like 2 hours to spend. So there are a few more places. I think 3 places because one guy said he can't come, and there were 2 free places before. So if anybody wants to join us for Italian.
So should we finish the discussion so I can stop recording?
Yeah,
Are you done? Okay, thank you very much.